How's it going, green screen viewers? Roshawn and I have a real treat for you. We're taking tonight's show to a whole nother level. Tonight, we're going to be just like you. We're students trying to learn something about our sustainable world. And for that, we got a special guest. Meet Adrian Townsend. How's it going, man?
I'm doing well, Adam. How are you?
Doing really good, thank you.
Hey, Roshawn.
Hi, thanks for being here.
Thanks for having me.
So we all want to know, what exactly do you do and what do you want to teach us today?
I want to talk about energy efficiency. That's what I do. I work with a group of mechanical engineers at KW Engineering, and we consult for our customers who are mainly industrial and commercial persons, entities, and we help them find ways to do what they normally do and save energy. So what's nice about the job is that we do a combination of fun things. We go out to sites, we get our hands dirty. We take information that we gather on site, we bring it back to the lab and do a little modeling, apply some science and math, and then you gotta write it up. We create some plots, charts, and a document that we can hand to the customer and say, okay, here's what we learned about your site, and here are some opportunities we found for you to save energy. So it's a good all-around job. You know, it's not just sitting in front of a computer all day.
Yeah, oh, now how would that look on your back?
Now, when we go on site, oftentimes we want to gather information, and so we'll bring instruments with us. This is one of them. This is a really handy tool. It's called a Hobo data logger. And this device can measure and record temperature, humidity, and light. And it has an external channel that you can plug other instruments into. Usually you'll tuck it away in a spot that doesn't inconvenience the customer and let it run for days, sometimes months, until we get enough data so that we can observe and learn about what's happening. Another neat tool is this power site right here. And this is really useful for finding out the power consumed by different devices. A lot of times there are projects from motors, pools. A popular project is pool pumps and putting a VFD, a variable frequency drive. That's a device that allows the pump motor to slow down when the pool doesn't need to be running at its normal speed. For example, when it's not occupied in the evenings, the filters don't need to be running as hard, the pumps can slow down and cycle less water and save energy because, after all, nobody's in there. This power site tool will go into the electrical panel and plug it in and directly measure the real-time power being consumed by the device. So again, it's fun going out and we get our hands dirty, and it's all about gathering information so that we can help the customers understand how they're using energy and find ways to save energy.
For sure. Seems like you really got everything straightened out too.
Mm-hmm.
So Adrian, what are you using this lamp for?
I brought some other toys here so we can do a couple little quick examples of the type of work we do. So I'm going to get a little technical for a moment. Efficiency. Efficiency, a simple definition is what you get divided by what you put in. Okay? And it's actually that ratio. So that's what efficiency is, and that's what I want to do a quick demo of here. In efficiency, there's two aspects to it in our work oftentimes. There's finding equipment that consumes less energy, same job, but uses less energy, so it's a more efficient equipment. And then there's efficient operation, which is running your systems more efficiently. So let's first talk about equipment, hardware. I have two lamps that I brought here. You might recognize these.
Yeah, I think that's a compact fluorescent, and that's a regular industrial incandescent light bulb.
Exactly. These bulbs have very different efficiencies. Some of you may already know what that is, but let's just do a quick demo and we'll actually find out which one is more efficient from data. So I'd like you to plug these in to the sockets on the lamp. We'll use this socket and this socket, and I'll hold one for you. So
Would you like that facing toward them, or I think they can get the general picture from the light that shines, huh?
Yeah, I think they will. Okay, is it snug? All right, let's see that it works. Okay, that one works. Let's plug in this one. So I have two other instruments, and I'll get you started with these, Adam. Here is a light logger. Okay, we're going to set this on to measure lux. Okay. It's a unit of measurement for light intensity. The sensor's here. So what we'll do is, for each of these lights, we'll measure the light intensity. Okay? And then we have another tool here. This device is called a kilowatt. That's a brand name. But it's a simple device that allows you to plug in an energy consuming device, an electrical device, and actually read the power it's consuming. So first, let's measure the light intensity from our first lamp. This is the incandescent bulb. So Roshawn, I want you to read off the numbers. They're going to bounce around a bit, try and come up with the average, and if it's hard to follow, just hit the hold button, okay? So let's turn this light on.
Let's give it a try.
I want you to hold this directly underneath it, about an inch or two below it, right about there. Hold it as steady as you can. And when you get a good number, Roshawn, let me know what it is.
About 211.
Okay.
211.
So we have 211. Let's not forget the units. Lux. Okay? Let's get lamp 2. Turn this guy off. Lamp 2. All right. So similar, Adam. Hold it about the same distance, same angle, same everything. Hold on. Let it run for a little bit. Okay. And tell me what you see.
Um, 407.
407?
Yes.
Wow, that's already a considerable difference.
Wow.
All right.
Now tell us, what exactly are lux? I don't think everyone knows what that is.
It's a unit of measurement for light. Light is measured in terms of intensity per area. Okay? And so, without getting into the very details of it, what's important is the amount of light photons that are hitting the area of this disk here. And depending upon how much light is hitting this area, so light per square area, light energy per square area, that's how you measure light intensity. And so lux is a unit of measurement for that. So similar to how you get watts, miles, meters, so on and so forth. So
Genius.
the next thing we're going to do is look at the energy consumption. So we already have this guy on. Roshawn, press the watts button to make sure we're measuring watts. Okay, and we have lamp 2 on. And what are you measuring?
The watts, meter, the number it says? It says 19.8.
19.8. And does it say watts afterward or a W?
It says VA.
Okay. Let me see. There we go. Now what do we have?
10.2 watts.
Okay. 10, I'll just say 10. 10 watts. VA is a similar unit of measurement. It's volt amperes. Watts is just more commonly used, so we'll stick with watts, okay? Now, let's switch to the other lamp and see what kind of power we're consuming. The top one. There we go.
Let's see the difference.
All right, what do we have?
37.3 watts.
Okay, 37.3 watts. And we don't worry about the decimal point. So, without actually dividing these two ratios out, when you look at these two, for lamp 1, the incandescent bulb, we found that it's outputting 211 LUX per 37 watts. Lamp 2, the compact fluorescent bulb, is outputting 407 LUX per 10 watts. So it's pretty clear from this which ratio is the bigger one, right?
So what exactly does that mean? Like what's the difference in, like, if you can define it in simpler terms?
If you were to divide these two numbers out, you'd have a certain number and you'd say that's light per watt, okay? It's similar to in a car when you talk about miles per gallon. Since we're interested again in what you get divided by what you put in, what's important here is that we're getting light, right? So what we're getting is light, and we measured that, and what you're putting in is electricity. Similar to in a car, the point of driving in a car is to travel some distance. So you talk about miles per gallon of fuel input. In this case, we came up with our own way of defining the efficiency of these bulbs by measuring in terms of lux per watt. Here, lux per watt. So if we divide this out, we get a number that's roughly 40.7 lux per watt. Whereas on this side, we get a number that's probably more like 2/3, about 0.68, about 0.7 lux per watt.
Oh.
So, I'm sorry, 7 lux per watt. So what that means is that this guy's 7, this one's 40. Do some quick math. This guy's consuming more than 5 times. I'm sorry, it's almost 5 times more efficient. Which means for a certain amount of light output, it's consuming almost 1/5 as much energy.
So you're saying that with lamp 1, if there's that little lux involved, and in that huge amount of wattage, then that means that it's consuming a lot more energy than it should be, then would be considered sustainable?
You could say that. Another way simply put is, if I need a certain amount of light in the room, why use this lamp that's consuming a whole lot of energy when you can use another one? And that's the kind of thing we do when we go out to our customers. We take information, we gather data, and we try and help them find ways that they can save energy from their processes. Sometimes they just have old equipment. You know, you'll have an old chiller which is helping them provide cooling, and we'll say, you know, listen, this chiller you have here is 15 years old. State-of-the-art chillers today consume a lot less energy for the same capacity. So you should consider making that investment. And what it's going to do is it's going to save you energy, and you can translate the energy savings by looking at their bills, translate that into dollars.
Is there anything else you'd like to tell our viewers, like any like specific events in your line of work that has defined, you feel has defined who you are and what you do, or anything else you haven't mentioned to us?
I'll say for me in doing this work, it's meaningful. I didn't always start out in this field. I was actually trained as an aerospace engineer, and I worked for a commercial airplane company for a few years before I came into this job. And what I like about this field more so than in that job is that, one, I work a lot more with my customers as opposed to just other engineers. I go out to sites, I have conversations with folks like I'm having with you about ways they can save energy. It's fun talk. It's good conversation. And in this job, more than in the other job I've done and other jobs I've had, the work I'm doing is directly contributing toward the world. You know, it's definitely making the place more green, making us all better energy users. And so I'll say this entire experience at this job, I've been here about 2 years now, has just been very meaningful and very positive. And I enjoy the work I do.
It's all right in your face. We can all see that. That's pretty much obvious. Hey, thank you very much. That's incredible.
I appreciate it. Thanks for your help with the demo. I hope it was useful and informative.
Definitely. Well, there you have it, viewers. Adrian Townsend. Now let's hope you all become disciples of a sustainable future. And I mean in the near future, too. Thank you.